Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see what is Python programming language and what are its various features. So these are the various topics that will be covered as part of this video. We'll start off with a brief introduction to Python programming language and see how does a computer execute code. We'll talk about compilation interpreters and what are the differences between these two. What is a bytecode and how it is related to Python based language. We'll also talk about Java, in which Java also generates a bytecode. We'll talk about Python virtual machine, which is called as PVM, and why this is used in Python. What are dynamically typed languages and static typed languages? And at the end of this video, we'll talk about some of the use cases in which Python can be used in DevOps. So Python is an interpreted, high-level, general-purpose and object-oriented programming language. This comes under the interpreted type languages. We have the other type of languages known as compiled languages. And Python is often considered as an object-oriented programming because it supports object-oriented concepts like classes and objects. It is free and open source and it has huge community support. It is cross-platform programming language. That means the programs that are written in one operating system can be used in other operating systems as well. That means the programs that you usually write in Windows can be run easily on other platforms like Mac and Linux. It has simple to use syntax and it is often considered as programmer's first language. That means if you are new to the programming, it is always suggested to start off with Python because of its easy to use syntax. And Python is used by many large companies such as NASA, Google, YouTube, BitTorrent, etc. And it is widely adopted in AI, natural language processing, neural networks and data sciences, along with web development, software development and system scripting. And in case of Python, the code is automatically compiled to a bytecode and executed. Since this is on the fly converted into a bytecode, it is more suitable as a scripting language. So we'll talk about this bytecode and what is this scripting language in the coming slides. So most of the Linux distributions that we generally use comes with Python pre-installed. Although it might have the old version of Python installed, it is better to update it to the latest version. And many tools such as SaltStack and Ansible, which comes in DevOps, are written in Python. These are the various features of Python. It has built-in high-level data types such as strings, lists, set, tuples and dictionaries. We are going to cover all these in the coming videos. And the usual control structures such as if-else conditions, while loop and a popular iterator known as for. It has multiple levels of organizational structures such as functions and methods, and OOPS concepts such as classes and objects. And we also have modules and packages, which is a kind of way we pack our complete Python source code. And we can compile on the fly to the bytecode. That means there is no a final artifact or the executable that is generated out of the Python compilation, just like your Java or GoLang source code. It is often compiled on the fly and the source code will generate the final output. So we'll talk about this in the coming slides. And it is object oriented programming. That means you can have classes and objects, and everything in Python is a object. It is dynamically typed and it has automatic garbage collection. We'll talk about garbage collection a little later in this series, but we'll cover dynamically typed programming in this video. And it also has support for a wide range of libraries and packages. Zen of Python. The main idea behind this Python series is not only to see how Python can be adopted in DevOps, but also to see how Python can be used as the development language. But in order to make production ready applications, we need to follow some guidelines and rules to make them production ready. The Zen of Python are basically guidelines for design of Python based application. Your Python code doesn't necessarily have to follow these guidelines, but they are good if you keep them in mind. In order to see all these guidelines, you can use import this in the terminal, specifically in the Python terminal, to get all these guidelines. So some of the guidelines says that flat is better than nested, readability counts, and simple is often better than complex. So these are all the guidelines that we need to follow. Let's say that we already have the source code ready, which is written in either Go, Java or CLang. Now let's understand how does a computer execute this code and what is the need for compilation interpreters. Computers can understand and run only binary code, that is only zeros and ones, which we call it as machine code. Machine code is base level form of instructions that can be directly executed by the CPU. That means CPU can understand only the binary code. Programmers use high level programming languages such as C, Python, Java, Go that closely resemble human languages, which is basically written using English words and mathematical notations. However, computers cannot run the code which is written in high level languages. So in order for the CPU to execute your code, we need to first translate this high level code into the binary code. To do so, we use compilers and interpreters. So we as a developer write the source code, and in order for the CPU to execute it, we need to convert that into a binary code. In order to convert into the binary code, we take the help of compilers and interpreters. Now, what is the difference between compiler and an interpreter? Basically, we have two different types of programming languages. One is compiled based languages and the other one is interpreted languages. So the languages whose programs we usually compile are called compiled languages, and those programs which we usually interpret using the interpreter are called interpreted languages. Now, what is compilation? Converting English like looking high level source code which is easily understood by the human beings to CPU understandable low level binary code is known as compilation, because CPU or the end system can only understand the binary code. So we often convert the high level programming languages source code into the binary code. Compile languages. When we write a program in C, C++, Go or Java, we have to compile it. Compilation usually involves translating your human readable code, which is usually written using the English language, into something which can be understood by the CPU, or we can call it as machine code. So the process of converting from the human readable code to the machine code is known as compilation. Upon successful compilation, your code generates an executable file like .exe or .oot file, depending upon the underlying hardware or the machine in which you are compiling. Let's say you are compiling your source code in the Windows system, then the final artifact or the final executable can be .exe in case of your C language. Or let's say that you are compiling in the Linux based operating system, so in this case the final executable will be .oot format. So depending upon the underlying hardware, your final executable extension will also differ. And one more thing we need to understand here is that this .exe file, if you want to execute, can be executed only on Windows based systems. That means this .exe file cannot be run in Linux. Similar is the case with .oot, which can be run only in Linux and not in Windows. So this is not cross compatible. That means the executable that is generated cannot be ported to various operating systems. And what will happen once you execute the final executable files? Basically it runs the operations which are defined in your source code step by step. Now one more advantage with compilers is they catch compilation time errors. Let's say that you have an error in your source code. So instead of catching that error during your program runtime, so compile based languages can detect those errors during the compile time only. That means if you have an invalid data type or if you have some errors written in the source code, so during the compilation fails. That means the final executable will not be generated due to compilation errors. Compile languages are usually faster and more efficient because you don't have to run your compilation stage every time. Once you have the .exe and .oot file, which are final executable files, so directly you can run them n number of times without needing to compile your source code again and again. So this is one of the example for the compile based languages. So we are taking the C example where it is just printing the hello world. Now if you give it to a compiler usually generates the exe file or OT file depending upon the underlying hardware, and usually the compiler or compilation stage will not be a single stage. In case of C language, there are 4 different stages like pre-processing and compiling, assembling your source code, and then linking with the dynamic libraries. So there are various stages involved in compiler, but all the processes are together known as a compilation stage. And the end result of your compilation stage will be your executable, which can be directly given to the end user for executing your program. So there is no need to share your source code, because for running this exe file you don't have to go through the compilation stage again and again. and this .exe file and .ot file can be directly understood by the CPU without needing to use any other tool or a software. Now coming to the interpreter languages, unlike compilers, the interpreters do not produce a binary executable file. That means you don't have any final executable which is in the form of .exe or .bin or any other extension that can be directly shared. Instead, each time when you invoke your program or the source code, the interpreter gets invoked and it reads and executes your code line by line. That means unlike the compilers which usually generates your final executable, the interpreter takes your source code in the real time, runs line by line, and then gives you the output. So Python is one of the best examples of interpreted languages. You can also call shell scripting also as an interpreted languages, and interpreted languages are usually slower than compiled languages because every time when you run your source code, let's say I have the Python source code, so every time when you execute this Python source code, it has to go through the interpreter and then give you the output. But in case of compiled languages, you directly have the exe file or final executable that can be shared. So running this exe file doesn't invoke the compilation stages again. Unlike the compilers, which usually catch the errors during the compilation time, the interpreters do not catch all the errors during the interpreter stage. Instead, interpreters catch all the errors during the runtime or runtime of your program. And interpreted languages are basically portable. So there is a lot to be known about this keyword portable, because the Python program which we usually write in Windows can be easily run in Linux or Mac operating system, unlike the compiled based languages. So we call this as portable, and we'll understand how the Python language is portable unlike other compiled languages like C or GoLang. Now one question we usually come across is whether Python is an interpreted language or a compiled language. Python is definitely an interpreted language, but it also has a compilation step. So what is this compilation step? Unlike the other programming languages like Go, C, which usually takes your whole source code and generates the final executable like .exe, Python code, which is in the form of .py files, are first converted into so-called bytecode, which is in the form of .pyc files. So these .pyc files are called bytecode, and they are stored with the extension .pyc. And what is this bytecode? This bytecode is basically low-level instructions that can be executed by the Python interpreter. Unlike the .exe file or .bin files, which are the executables out of compiled languages, which directly executes on your CPU, the Python bytecode cannot be directly executed on the CPU. Instead, it can be only read with a component known as PVM, which is Python interpreter or Python virtual machine. Now, instead of executing your instructions directly on the CPU, you are executing instructions on the PVM. Now PVM is responsible for converting those instructions into low-level instructions or binary code which can be understood by the CPU. So this is an important step inside the Python language, which is instead of directly converting your py files into the low-level language, we have the bytecode. That bytecode can be understood by your Python virtual machine, which is responsible for converting your source code into the low-level code or the machine code. Now what is bytecode? Bytecode is a program code that has been compiled from your original source code into low-level code designed to be consumed by interpreters. So here this low-level code cannot be understood by the CPU yet. It can be understood only by the interpreter. That means the source code is first compiled into a bytecode. This bytecode will be consumed by a virtual machine, and this virtual machine is now responsible for converting that bytecode into CPU understandable machine code. So this virtual machine can be your Java virtual machine, and it can be your Python virtual machine which is used for Python. So in case of Java, so we have the .java files, so which are first compiled into .class files. So these are known as bytecodes. So this bytecode is converted or given to a Java virtual machine. This is responsible for converting your source code into zeros and ones, which is basically your machine code. So in interpreted language it is somewhat different. Now let's understand bytecode in Java a bit. When we write a Java program, which will be basically in the .java files, so these files are first compiled into .class files, which are basically bytecodes. So these bytecodes cannot be directly understood by your machine because this is platform independent code. It is not meant to run on a specific platform. So that is why you cannot directly run in any of the platform. Instead, this bytecode has to be given to one virtual machine. This virtual machine is responsible for converting your bytecode into machine code which is specific to your hardware. Let's say this bytecode has to be converted into a machine code which can be understood by the ARM processors or x86 processors. So that is why we need to have a VM, because these bytecodes are platform independent. These are not specific to your Linux platform, these are not specific to your Windows. That's why you cannot directly run in any of these machines. In simple words, we write our source code once, compile them into bytecodes, and run these bytecodes anywhere with the help of the VM or the virtual machines that are independent for Windows, Linux and Mac OS. You can take the same bytecode and can run in all the operating systems with the help of VMs for their dedicated operating systems. Now the resources required to execute bytecode are made available by the JVM. So JVM knows how to take your bytecode and convert them into your machine code that can be understood by your CPU. Hence, Java is both a compiled and interpreted language that helps Java to move more programs easily from one system to the another system, because the Java programs which are usually written in one operating system can be easily ported to the other operating systems as well. Now let's say that you have a simple Java file which is in the format with the extension .java. So with the Java compilation stage, they are usually converted into .class files, which is basically your bytecode. Now this bytecode is platform independent. That means I cannot dedicatedly run it in any of the machines. So with the help of Windows JVM, I can convert it into Windows specific machine code and I can run it in Windows. And with the help of Linux JVM, I can take this bytecode and then convert it into Linux specific machine code and I can run it. So similar is the case with the Mac OS. But in case of compile language, this is not possible, because compile language usually generates in machine specific executable code. That means if the executable is only meant to be run in Windows, it only runs in Windows and it cannot run on Linux. Now let's understand Python virtual machine a bit. The main idea of covering all these topics is to make you comfortable in Python, because anyone can write a Python code, but understanding the internals of Python programming language and how the Python programming language works internally is necessary to understand and write much better Python programs. When we run a Python program, two steps will happen. In the first step, the code gets converted into a bytecode which is of the format .pyc, which is basically cannot be understood by the CPU. In the next state, the bytecode gets converted into a machine code which is usually understood by the computer. The second step is done by the PVM, which is also known as an interpreter in case of Python, that converts your bytecode into a machine code for the given operating system. So let's say that you have taken a PYC file and you have given it to a PVM running in the Linux operating system. Then this PVM can take that bytecode and convert into machine code that can be understood by that operating system or the underlying hardware. That means the PYC files are platform independent. You can take this PYC file and then you can run it in any of the operating system, provided you are giving it to the correct PVM. Now this is the overall execution flow. You have the source files which are usually written in .py, and they are given to the compiler, which usually generates the bytecode which is in the format .pyc, and this pyc file has to be given to the PVM, because PVM can only understand the bytecode and then it can generate the machine understandable machine code. So if you are taking the pyc files and running it in Linux, still the program works. In the same way, if you take the pyc files and run it in Windows, so Windows PVM can convert those bytecode into the machine understandable code. In short, this is the difference between compiled and interpreted languages. Now, what is dynamic typing in Python? So we have come across many programming languages like C, C++, Java, etc., which are basically static typed languages. So what is this static typed languages? In static typed languages, we need to declare the type of the variable before assigning values to them. Otherwise, they will lead to compilation errors or compile time errors. But in case of Python, you don't have to mention the type of the variable. Let's say you have taken the C language as an example. So in order to for the variable c to store an integer like this, I have to give the type of the variable or set the type of the variable to int. Now coming to the Python, it is dynamically typed language in which you don't have to declare the type of the variable before the runtime. So the interpreter does this type checking only when the code runs or during the runtime, and the type of the variable is allowed to change over its lifetime. Let's say initially I have set c equal to 10, and during the runtime I can also make c is equal to hello, thus changing the type of the variable from integer to string. So Python is dynamically typed language in which the type checking is usually done in the runtime, and there is no strict declaration of type of the variable is needed before the runtime. So this is the difference between static and dynamic. In static, let's say we have the C language based source code in which I am storing three numbers, numerical number 1, 2 and the sum, which are basically integers. But in case of dynamic typed language, just like your Python, you don't have to set the type of the variable before running it. Now let's consider this short example in which I am trying to add an integer with the string. So in case of static typed language like C language, this will throw an error during the compile time. But in case of interpreted based languages, let's see how this is not a issue. If you see clearly, I'm using an if condition, and it is if false, that means it is if 0. So if it is if 0, control will never come to this line. That means 1 plus 2 will never be executed in case of Python. So even having this kind of an addition where I'm adding integer with string, still my Python program runs without throwing any type error. But if you're trying to add directly without using if condition, so this statement will be always executed. So in this case, the type is checked and the type error will be raised. And also we said that in the dynamic typed programming language, the type of variable is allowed to change during its lifetime. So initially thing is set to be hello, which is of type string, but during the runtime I'm changing this thing variable to 28.1, which is basically a float. So in dynamic typed languages, you are allowed to change the type of the variable during the complete lifetime of the variable. Now these are some of the use cases that we often come across in DevOps. For automating the complete DevOps lifecycle management, we can use Python. For automating the infrastructure deployment and configuration management, we need Python. For automating boring and repetitive tasks and from day-to-day monitoring tasks, we can use Python. We can use the DevOps tools APIs to completely create an automation around your complete DevOps tools. For the CI/CD pipeline automation, also we can use DevOps. For creating CLI tools, just like your kubectl or Git CLI, you can create your own CLI tool and work with any of the DevOps tools using Python. You can also create basic web and GUI development in Python, which are specific to your DevOps scenarios. And also for basic API development in DevOps also, you can use Python. Thank you, and I'll see you in the next one.